So it's been a lot of interest in China, actually, in the ideas in the decarb plan, and has gotten us some projects in China. So that's where we stand with it. So thank you.
Good morning. Thank you for the opportunity to come here and speak. I greatly appreciate it. Thank you to Elena for inviting me. Thank you for having me. I do want to apologize. I do present a little fast, and it's in English, so I apologize. I'll try to speak slowly and clearly. And today, I'd like to talk about not only designing the fifth facade, but really about the architectural design process. How many individuals in the rooms are in architecture? How many are in landscape design? Urban planning? Okay. Interiors, materials, industrial design? Okay. Good, so mostly architects, designers, landscape. And so just a little bit about myself. My name is Colin Rolfing. I'm the Sustainable Design Director for HOK. HOK is a global design, engineering, and sustainable consulting firm. I have a background in engineering, though, so I get to work with architects every day on new design processes that try to drive efficiency into their projects. And so yesterday I gave a presentation about the fifth facade, so I apologize to many of you that were there. This will be a repeat of some information. But the idea was that the fifth facade is this blanket, this epidermis that populates our urban space. And it's not just roofs, and it's not just landscape. It's really the architecture, the planning, the people that inhabit that space. Everything is synergistic, and everything affects efficiency and optimization. And so, you know, the intention of the discussion yesterday was trying to make our built environment, something that's hardscape, uses a lot of energy, into something that performs more like the existing ecology on that site. And once again, it doesn't need to look like this. It just needs to perform like this. And so there's three topics that I want to cover today that are new trends and very important to the design world today. These are things that we try to use on many of our projects. It's new ways of thinking, new ways of designing. It changes the design process completely. So one is net zero, or net zero carbon design, and Gail mentioned kind of the process to get to that with existing buildings. I'd also like to briefly talk about the Living Building Challenge, which is a step beyond net zero energy. It focuses on net zero water, materials, etc. And then finally, biomimicry, kind of utilizing design principles to help achieve the first two. So there is a lot of talk about net zero carbon. And my company and Gail's company were both signatories of Architecture 2030, which hopes to have all of our building designs down to net zero emissions by the year 2030. So how do we do that, though? You know, there are some projects that are net zero emissions, but some are very small in stature. The others are very large. These are both great projects, but you either have to have a very small square footage or a very, very large budget to achieve them. So how can we design net zero emission buildings that are of the most typical size in the US and in many other countries, around 200,000 square feet or 20,000 square meters? And how can we make them affordable? How can we find a payback for a client using technology that's available today? Not crazy technology, not technology that's 10 years away, but technology that we have now. So, as you begin to design a building, before you put pen to paper, and I know that we all love to sketch, we all love to draw, but I usually have to go into meetings at HOK and I have to slap the pen out of people's hands or tear up their initial sketches because they start sketching before they realize what the building functionalities are or how much the building might use energy-wise. So we need to ask these questions. What would the building look like if we really wanted 100% daylight? What would the building look like if we wanted to orient for natural ventilation? what would the building look like if we wanted the HVAC and mechanical systems to have the most efficient zoning? We don't ask these questions before we start sketching, and we need to. So this is a process for net zero where we're really looking at these 6 steps first. And we need to focus on all of the passive ideas before we begin sketching. Understand your climate. Understand what the conditions are for temperature, humidity, solar access, etc. Reduce your loads passively, massing, orientation, the amount of glazing you have in a building. Utilize free energy and water. How much water can you collect for a particular climate? How much daylight can come into the building? What can you utilize as heat exchange on site from other buildings? Then you take a look at mechanical systems and renewable systems. Honestly, renewable is the last thing you do. You should plan for it, make sure you have enough space if you want to get to net zero, but it is the last technology that you should integrate for payback purposes, etc. So this is an example of design that is not necessarily well adapted. These are forms that are fun and very interesting, but they disregard site, they disregard program, and they disregard scale. Sometimes I feel like we as designers, we design buildings that disregard habitat, disregard ecology, disregard climate, health, and productivity. And so before we start these sketches and these fun shapes, we can really, by looking at a site, by looking at the conditions of the building, we know to an extent, based upon building physics, what that building might look like. And quite honestly, it saves you time. In the professional world, when you do too many study models, more than half of them are usually wrong for that site. They're not efficient for that site. So utilizing this process can actually save you time and energy on a design engagement. Before we begin designing a net zero building, build a dumb box and put it into energy modeling software. There's multiple softwares available, but all you need is a dumb box that's roughly the size of your building, and you can find out exactly what your loads might be for that building in that climate zone. Use this as a starting point. We can easily see that we're going to have a large heating load in this building, but that actually it's much more heating load for BTUs, for the energy use, and it's actually less cost. So if you were a designer, you would focus on the heating. If you were an owner, you would focus on the lighting load. It's going to cost you the most. So you need to know the difference between cost and energy use when you're designing a project and engaging a client. The important thing here is that once you build that first dumb model, you then model again, and model again, and model again at each design step. Each change in design, you find out what your iterative process is. If you wait and you design an entire building and you do an energy model at the very end, it's too late. You can't change things as easily. It costs money, it costs time. You need to continuously model. When you're looking at these forms, the last thing we should do as designers is fake it. I see a lot of this in the industry, and we call these well-behaved arrows, where we draw little diagrams and the light comes in and it bounces off the roof, and then it bounces off the ceiling, and then it bounces off the floor, and it goes through a door, and this room down here is 100% daylit. And we are better than that. We have to use real models, real daylighting, to find the approach that will allow us to get to net zero energy. And in this case, an office building of 20,000 square meters, we will need 100% daylight in that space. So again, building physics, massing orientation dictate the size and shape of this building. Now, in some cases, the layout should also consider natural ventilation potential, computational fluid dynamics. This is a campus that was oriented not only for solar access, but also to pull natural ventilation and occurring winds off of the Red Sea and use a solar tower to enhance the velocity of that wind. We were actually able to reduce about 60,000 square meters of conditioned space because of this. This actually was not the case for this project. This project was in a climate where natural ventilation was only possible for 12% of the year. So we only had to consider solar gains. Operable windows were not included. We had to make up the energy elsewhere. Once we have our massing and orientation, we need to look at window-to-wall ratios, solar analysis on the windows. Design your facade to respond to solar axis. You can see here that we have, this is a hot climate. We have less solar gain on the bottom right. Therefore, we can have more glazing. We have a lot of solar gain in the top left, so we should have less glazing for solar heat gain purposes. This becomes a design tool. These are the aesthetics, I think, of the new design generation, is using modeling to create the aesthetic. Find that appropriate window-to-wall ratio. When you have too much glass, and I know architects love glass, it's very sexy, but it's very, very inefficient. There are new technologies coming out, but even the best glass is 3 times worse than the worst wall. So find that appropriate ratio where you have appropriate glazing, not too much, not too little, to save energy. Because as you design an appropriate facade with appropriate glazing that's high performance, has the right orientation, you can then get rid of systems. You can reduce the size of your mechanical systems. You can only specify 1 chilled beam instead of 2 chilled beams, and that saves costs in the project. And these are the realities that we have to face as designers going out into the profession to ensure that all of these systems work together. We can't have an efficient HVAC system if we don't have an efficient envelope. We can't use underfloor air if we don't design the appropriate floor-to-floor ratio, floor-to-floor height. So, it's important. I'm not going to go through all of these strategies for this net zero project, but it's important to note that when you take away one, it affects the others. And your model is based upon all of these things working together in synergy. So here's the image of our net zero project. We did obviously leave some room for renewables. There was an 80% reduction in energy use just by using appropriate design, massing technologies, and mechanical systems that are off-the-shelf technology today. Nothing crazy, nothing new. The bottom left image is just a net zero construction with room enough for renewables. So if you want more information, there's a website, netzerocourt.com, that talks about all the details of the strategies. But the important thing to note is that this is a different design process. This is a process that looks at modeling first and then allows for aesthetics and sketching. I just wanted to talk briefly about the Living Building Challenge. And I don't know if you guys have heard much about it. It started in the Pacific Northwest of the United States, and it is requiring, it's not like LEED, it's requiring all these prerequisites, all these requirements for these buildings: net zero energy, net zero water, the elimination of red list materials. So you have to achieve all these things to get a living building. And I just wanted to show you the red list because beyond energy and beyond water, net neutrality, there's a large focus today, and if anybody is focused on material science or interior design, there's a very large focus on red list materials and unhealthy building products. Now, all of these materials right here are not allowed to be in a living building. And it's very difficult to find products and manufacturers that can tell you we don't have these things in our products. Human health is of the utmost importance. Every conference I've attended recently, human health has been a major topic of discussion. And the reason being is because the majority of our building materials are full of toxins. And so, the red list allows us to reduce to, identify those items and remove them from the project. This takes a lot of time. It's very labor intense. One way I think that we can achieve net zero emissions, one way I think we can achieve removal of the red list items is by utilizing biomimicry. And this is the third topic and the third trend I'd like to discuss with you today. 3.85 billion years of experience in over 100 million species. That's a lot to learn from. That's essentially very well adapted design. These organisms have adapted over that long period of time, and they are super efficient. in nature. And so I just want to make sure that you guys know what biomimicry is. It's not biomorphic. This is a beautiful project in Chicago. It's resembling or suggesting the form. That's not biomimicry. Biomimicry can also be this, but biomimicry is something more. It's also not biophilic, which is essentially an attraction or connection to nature. Biomimicry can be this, but biomimicry, again, is much more than this. It's essentially utilizing life's principles. So you look at organisms, you look at the way they function in life, and you're pulling their performance. So, for example, being locally attuned and responsive. That lily, that plant right there, it opens and closes based upon rising water levels and changing sun patterns. Again, maybe our building facades, our envelopes, should do the same thing. Open and close with the seasons when appropriate. Using the principle of being locally attuned and responsive, we can find performance with biomimicry. We can find performance with biomimicry in a city. This is a large city that was developed as a master plan, but it was laid out using principles of nature. It was laid out using these principles: environmental performance metrics. Our city should store and collect as much water as the existing ecology. Our city should filter pollutants from the water. Our city should have biodiversity. And essentially, this city preserved existing spaces. It preserved streams that were existing. It then implemented technology to perform the same way. This technology actually stores water during monsoon seasons, and then when there's dry seasons, it brings water back up to the surface. We also have step-down districts that allow for stormwater control, just like beavers do. Same thing is true for energy. We're able to identify areas where we can produce energy to focus on net zero carbon. And here's just an image of this city. And I want to finish up here with just 3 quick examples. I know I'm over my time. Of biomimicry. I think it can be very important at the building scale. This is an example of a project we have in Colorado. On our site, we had black-tailed prairie dogs. And all those prairie dogs have tunnels. There's an innie hole and an outie hole, and they're all oriented in this direction. That direction is the direction of the prevailing winds in the summer. And we actually measured the airflow in their burrow, and it's 2 air changes per hour, which is code minimum for office buildings. So why can't our office building be oriented in the same direction and utilize that same fluid dynamic equation to drive natural ventilation through the entire space? This is a project in Brazil where we looked at bromeliads, which is a flower that stores water but also has an amazing structural system. So this water concept idea was utilized for the central atrium to support the structure and also store water for flushing, for irrigation within the space. It uses the same functionalities as local plants in the region. And then finally, we can look at biomimicry for building facade ideas. This is Project Haiti. This is a living building design pro bono we did in Haiti after the earthquake. We looked at local trees and plants and bark, and we designed the facade based upon those principles. When the bark comes off and it's very rough, it provides self-shading. So there's solar shading for the building, but it also creates an air pocket. That air pocket has convection and air flows through it, and it allows for the building to remain cool. So using that same principle of locally attuned and responsive, we're able to design buildings. And I think these elements, these design ideas are the trends right now. Everything Gail has talked about and I've talked about. The way we design is different. We have to be engineers, we have to do calculations, we have to be researchers, we have to be scientists in order to find a design that's well adapted and efficient. And I think that's something to look forward to in your future design careers. Thank you.
On a eu là 2 interventions qui élargissaient le propos des toits à des questions environnementales et des questions donc architecturales beaucoup plus larges. Moi, je vais me permettre de faire un petit retour dans l'histoire, un petit retour sur le toit comme sujet d'architecture et de regarder à travers une période assez longue en quoi le toit a été traité, pensé par les architectes essentiellement dans le cadre de Paris. Un lieu un peu aussi de rêverie, d'imaginaire, à travers le cinéma et Jean Marais sur les toits avec Fantomas. Le toit, le rapport au toit, le rapport à la nature. Le toit, c'est d'abord pour se protéger de la pluie, comme le rappelait Philaret, dessinant Adam chassé du paradis, mettant ses 2 mains au-dessus de la tête pour se protéger de la pluie. Le toit, donc, qui contrôle la nature, qui nous protège, mais le toit aussi qui permet de contrôler la nature, qui permet en effet de l'amplifier. Les jardins suspendus de Babylone, en effet, où là, le toit devient une sorte d'exagération, de contrôle, une sorte de manière de revisiter le paradis, l'Éden perdu, dans un jardin magnifique qui surplombe tous les bâtiments. Et aussi, c'est intéressant, les jardins suspendus de Babylone, c'est une sorte d'imaginaire qu'on va retrouver à travers l'histoire de l'architecture de manière extrêmement fréquente, et y compris dans des projets contemporains. Le toit, à l'époque médiévale, en effet, on couvre de manière assez simple. C'est des toits à 2 pentes, assez hauts, avec des grandes pièces de bois, et avec cette idée d'une ville extrêmement découpée, avec des toitures qui montent très hautes, et au milieu, donc en effet, quelques monuments qui émergent. Mais ce rapport au toit, il va être réinterrogé par les architectes à partir de la Renaissance, où le modèle cesse d'être de l'architecture, on va dire, vernaculaire. Et j'ai que 15 minutes. Bon, alors le toit. Le toit. Donc, en effet, la Renaissance